Hello, this is Kevin Dunn, representing Team 8 of the Computer Science and Engineering Department. I'll be walking you through our application, SIFT, that we made with our sponsors, the Hail team at Sonalists. SIFT is a web application built using the Angular framework on the front end, with a backend and database implemented with Node.js and MySQL, respectively. SIFT was developed with the purpose of streamlining the analysis done by Sonalist employees on text data collected from interviews, focus group meetings, and other such means. SIFT allows Sonalist employees in a variety of roles to collaboratively analyze data in a project-based structure. Users will begin either by creating an account for SIFT if they have not logged into the application before, or by logging in with their pre-established credentials. This brings them to their user dashboard, which contains a list of every project they have created so far, along with options for creating a new project. For the purpose of this demo, we'll use a project that I've already uploaded some data for and configured project settings for. Opening up a project brings you to the project console. This serves as the main hub for SIFT functionalities, having buttons to every other functionality within the application, along with displaying visualizations about participant demographics. The progress bar shows how many documents have been uploaded against the goal for this project, and the bar chart displays a distribution of demographic responses. You can toggle which demographic is displayed with the dropdown. Once participant data has been uploaded, the user can progress to the main functionality of SIFT, the text analysis page, where users will interact with the documents they've uploaded to explore themes in the text. In this example, we've uploaded some sample responses to a survey sent out to senior design members asking about their experience with the program. Looking through the responses, I noticed a lot of mention of communication being an important aspect of the program, so I've created a communications column to denote this, along with creating a subcolumn belonging to this column, denoting communication with the sponsor. I'll also create another subcolumn that denotes communication with team members being important, and assign it a contrasting color from the others, assigning it to this parent column. I can then go within the text, highlight desired sections, tag them, and then drop it into these subcolumns. I can then open up another document that I've uploaded, highlight this text, tag it, and then drag and drop it into another column. These columns will be then used to create design seeds that will serve as inspiration for future projects for the Hail team. I'll now create a design seed that consolidates some of my findings, denoting that they all relate to the development of soft skills in preparation for the workforce. The design seed appears here, and I can drag and drop some of my findings into this design seed. If we go back to the project console and then to the design seeds page, we can see this design seed that we created in the analysis page appear here, where we can then append media or other documents in support of this design, including design mockups. Currently in development is automatically suggesting themes to the user based on analysis on the data from a hierarchical clustering algorithm, which our teammate Hasib Khan, who developed the algorithm, will now explain.
One important way that SIFT will help Sonalist employees in their workflows by assisting in thematic analysis, where the website will extract keywords from standardized uploaded documents that will correspond to themes present in the text. The documents are parsed based on the interview questions. Each response becomes a data point grouped by those interview questions. The text data is then cleaned up and standardized. As part of the processing, the text is reduced to the root terms via lemmatization. Unigrams, bigrams, and TF-IDF vectors are then generated for each response. For those three natural language processing techniques, an agglomerative hierarchical clustering algorithm is used to construct a dendrogram for each of those interview questions. The dendrogram is formed by continuously averaging the two least similar vectors until they converge to the root. Cosine similarity between two vectors is used to determine which ones will be averaged at each step. The features with the highest scores are returned. The website generates graphs for each NLP technique for each of the interview questions using the highest features. The user can then evaluate the graphs holistically and generate the appropriate themes summarizing the dataset based on the keyword extractions.